Hi, welcome to another video tutorial. In this video tutorial I'm going to be going through the run length encoding algorithm, and this is used to compress data so that it takes up less space in memory. So run length encoding is a lossless algorithm, that compression algorithm, and that means that the compressed data retains the same detail as the uncompressed data. It works by taking sections of repeating data, otherwise known as a run, in a file and representing them as a frequency value and one copy of that repeating data. These are often called frequency data pairs, so frequency data pairs like that, and say for example I had some text with 3 A's in a line, then I would represent it as 3 and then A there. And that would be my frequency data pair, and I'm going to go into that in a bit more detail in a second. And the other thing to note about run length encoding is, depending on the data and whether a flag is used to indicate a run length encoding data can take up more space than the original data, so you can get negative compression. And what I mean by negative compression is where your compressed data is actually larger than your uncompressed data. Okay, so let's look at an example of how we might use run length encoding to compress some text. Okay, so this is some text that I've got, and if I decided to store this as ASCII codes, it would look something like this. Okay, so that's what it would look like if I stored it as ASCII codes, and for simplicity I'm just going to say that each of these ASCII codes and each of the numbers that I store referring to the frequency of a bit of data is going to take up 1 byte. If I stored this, if I compress this with run length encoding, this is what it would look like. Okay, so this form of the data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 bytes, because I've got 17 ASCII codes. But simply storing them as frequency data pairs has managed to reduce the number of bytes that I need to store my data to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that is simply how we can compress some text with run length encoding. But this simple method of compression isn't particularly efficient if we have some more random text. So this isn't very random text because we've got the same character repeated many times, so it makes this type of compression particularly effective. But one way we can work around the inefficiency of using run length encoding with more random text is by using a flag to indicate a run. I'm going to show you how we do that with another example now. Okay, so this is a different string of text, and you can see that I've got a few more examples of characters where there's only one occurrence of the character. So this will demonstrate quite nicely how using a flag can improve the compression that we can do with run length encoding. So if I represented this as ASCII codes, this is what it would look like. Okay, so that's what my text would look like with ASCII, just simply represented as ASCII codes. And if we apply our basic run length encoding to this, this is what we get. Okay, so that's what we get if we apply basic run length encoding to it. Just represented as ASCII codes, I've got 15 bytes of data here, because I've got 15 character codes. Represented using simple run length encoding, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes of data. So we've done a little bit better with simple run length encoding, but we can do even slightly better than that if we use our flag. And the flag that I've chosen to use is the 255. And what we do to use a flag is whenever there's a run of data, we put 255 in front of the run. So we say 255 for 97 to represent this run of A's here. And whenever there isn't a run of data, we don't have to put the frequency. We simply put the character code for example, C in this case over here. So this is what it would look like if we represented this data with run length encoding using the flag 255. And we've managed to reduce it to 13 bytes of data using the flag 255. So another slight improvement there on the size of the data. So that's just a quick run through of how you would use run length encoding to compress text. You can also use run length encoding for different types of data such as bitmap images. But to compress data with a bitmap image, you simply apply the same methods as we've done with this text.